Hello, good evening. Hi everyone. How's everyone doing? You're all geared up for day two or no? Yes, no, not doing great. How was everybody's day? I hope everybody is all pumped up to understand and learn about new things that they are going to learn today. Yes, no, I would just appreciate all of you replying on chat so that we know that y'all are all here and just say a hello maybe if y'all are all okay with that. So yes, we will start in a few minutes because let's just let everybody join. Let's give them another 2 3 minutes, and we could start at like 6:35, so that it's good to go. I mean, everybody is here and we can just start. I can see everybody on chat feeling low because of rain. Okay, interesting. Yeah, it's rainy days everywhere. So I see that everybody is facing their own challenges with respect to that. Am I audible? Clear? Lagging, somebody mentioned lagging. Okay, let me just recheck my connection once. Don't worry about that. We will start in a few minutes as is. So let's just, let everybody join in. Then we can start. You can hear me now clearly. Is the voice clear? What is happening? Can you hear me? Can you not hear me? Give me some updates regarding that so that then we'll be good. Meanwhile, I'll just share my screen also so that you can see what we are going to be starting with today. Can everybody see my screen? Is my screen visible? I think it should be. What kind of sound is troubling is what even I'm trying to figure out because I can't listen to any sounds. Can you hear me now? I think I should be clear enough now, right? Okay, just give me a moment. I can change my headphones if that's good. Is anybody able to hear me or not? We are already close past 6:30. So should we just go ahead and start? I think you can hear me now clearly. Just a second. Okay, so let's quickly start with today's session. What we'll do is we'll do a quick recap of what we did yesterday, and then next we will move on towards looking at the concepts that we have to cover today. And since there are three modules to cover today as well, we will get on with it, right? So that's exactly what we will go on with. So, can anybody tell me what all we covered yesterday? Can everybody type it on chat? What all did we cover yesterday? We covered certain things about the iris data set, right? Today is day 2 of your boot camp. So we completed certain things yesterday. So that's exactly what we would want to talk about, right? So we did talk about types of ML. We spoke about what else? Somebody wrote types of ML. The data set. Yes, we learned about the iris data set, which is true. Uh, except for that, what else we learned? We learned much more concepts, right? Not just this, but more than this. So we covered important concepts, so we will go through it. So let me just go over a quick recap. In 2 minutes, we'll do a quick recap of the things that we covered, of the concepts that we covered. First is what is machine learning. We covered that, right? Like the difference between traditional programming as well as machine learning. Then we also saw types of ML, like how we can do supervised learning, unsupervised learning, as well as reinforcement learning, right? Then we also learned about reinforcement learning, which is applicable in games and how you can really work ahead with it. That is also something that we saw. Then what we saw was another thing, which is a project life cycle, correct? So in the project life cycle, we learned about the 10 steps through which you would go on from the data to the output, right? So that is exactly something which we saw and which we were understanding and seeing what are the steps that are there, right? So that is something which we really were focusing on, right? While we were trying to understand about the theoretics of ML itself, correct? Then we also understood about the data, right? The iris data set. What all did we understand in that? Like, what is a data set? What does rows, columns, etc. really look like? Features, labels, and how does the iris data structure, like the data set itself, look like? And what its structure is like. Then we also learned coding, right? We did some hands-on coding. Did we do that or no? We did some hands-on coding. Everybody was able to code, correct? So what did we do in coding? We tried to learn about the sklearn datasets, how we can load the iris dataset. And then we also learned about how we have to split it into two parts, that is into X as well as Y's. What are your X? X is your number of features, whereas Y is your target variable, which is used to predict, right? That is something which we do use, right? Then post that, what else did we learn? We learned about how to build your first ML model, right? We learned about how to really use the scikit-learn library, right? That is something which is very important. That is how we use the scikit-learn library to its optimal advantage, right? Then we understood about how to use the decision tree classifier model and how it looks like a real life decision tree that we would make in order to come to decisions, right? Then we also use the model.fit method to train the model, and then we use the model.predict method to get predictions, right? That is also something which we did. We did go through all of this, right? That's a very important aspect of understanding the theoretics of ML and then going towards the different concepts which are a part of it, right? So now we will move on further and learn about these modules and what our theme is today. So the theme for day 2 is majorly from model to insights. So till today, you learned about how the model is created, right? And you do training, you do testing, you do evaluation. All of that is something which is a process that you are involved in, right? Post which, what all you will learn? Tomorrow we'll do the visualization part, the more beautiful part of it. Like how do we really create graphs, charts to really display them. Today, majorly what we will focus on is data pre-processing and cleaning. That is our first module that we will ensure to complete. That is to understand how do you really clean data, because data is usually something which has a lot of noise present in it. So we need to clean it and pre-process it so that it's brought to the same standard as needed in the industry, right? That is one. Secondly, model training and evaluation, right? So you will just train your model and then evaluate it further, right? So what do you do while you train your model and then evaluate the model? Then what you do next is improve your predictions, correct? So when you're doing that, what is happening is you'll ensure that the predictions are something that are typically accurate, right? So when it is predicting, you need to ensure that the model accuracy is pretty good. So these are your three modules which form the central aspect of machine learning overall. So for you to know all of this is very, very important. So I would suggest that all of you focus on these aspects of the modules today. All right. Now, let's get started with module number 1. What's it? Which is nothing but data pre-processing and cleaning. So here, the kind of questions or discussions that we'll have is we'll try to target these questions. That is, why do we split into train and test sets? That was one question which a lot of you guys asked me yesterday, right? Like, why do you do that? We'll try to answer that. Okay. Then secondly, using the train test split from sklearn.model selection. So we'll use this particular method which is available in a library directly for your train test split so that you can train your model accordingly. You don't have to really, roam around, look for methods which can help you do this task. So that is your train test split method from your sklearn.model selection. Okay. Then third is something which you learn about data cleaning, pre-processing. That is handling missing values. Many times in your data sets, you might come across missing values, right? Where the data is completely missing, it's off the track and so on. So you will get some basic intro about it, that how we can handle missing values. Then how do you really scale or normalize the data? Now when we say scale or normalize the data, say your age is between 0 to 80, just giving a normal average. So between 0 to 80 would be your age parameter, right? Number two, what will happen is you will have some parameter, say something like salary. Salary is also something which would be there, right? Which would exist. It's not something which you can, do away with. So whenever that's the case, what you do is the range would be say in lakhs or thousands depending on whatever the salary of the person is. Okay. Now, what is happening over here is that the ranges for them are different. So that's why you will have to scale or normalize the data. That is, the values are not in the same range. It's not falling between 0 to 10 or 0 to 15 as it should fall in. So that's a major, major thing. When we talk about scaling or normalization of data, why do you actually need it, right? Now, let's go to the next step, that is understanding why pre-processing matters. Okay, why would that typically matter for you is also very, very important. So raw data that you have in any data frame, in any Excel sheet, in any CSV would be messy or inconsistent. It would be highly possible that the raw data is messy. It's not something which you'll always have in the perfect state. It's quite not possible. Okay, so that is the case. And ML models usually work with clean and well prepared data. It's a well structured data with which usually the ML models will work best. What will pre-processing ensure? Pre-processing will always ensure that you have better accuracy, you have faster convergence and reliable results. Okay, I'm seeing the chat and a lot of you are saying that the voice is less audible. Is that the case? Are you facing such a challenge? How many of you are able to hear and how many of you are not able to? Just quickly, give me a show, give me a tag over there that you are not able to hear or able to hear. Just don't say audio issue. Give me the clear problem. What is it that is happening? Because I can see that I am on full volume right now and others are able to hear. So that's the reason why I'm asking as to what the problem is. It's low. Somebody saying able to hear, voice is low. Whereas I'm on full volume. Let me just check if there is something else that I can over here. Okay. Can you hear me better now? I think there was some setting which was off. Can you hear me better now? Can you hear me better now? Yes, no. Give me some response around the same. Can you hear me better now? Am I audible clearly? People are saying yes as well, so I think that I am audible now and it's not an issue. Okay, fine. I think it's clear now. Are you able to hear me now? Is there any echo? I think it should be gone now. Okay, fine. We look at the different aspects now. So, pre-processing, why is it important? So, pre-processing typically ensures that you have better accuracy in your results. You have faster convergence. When we talk about faster convergence, it is nothing but it will ensure that the learning rates or the error that you're trying to minimize is getting closer to zero. That's exactly what you are wanting to get at. That's the major goal. That is faster convergence. And then the next step is reliable results, which is very, very important again. So that you can rely on it and you can get your predictions, right? So that is one thing. So the basic funda, or you can say the basic goal of ML is garbage in, garbage out. So if you feed it in garbage, then it will always throw garbage out. So you need to ensure that whatever you're giving as an input to the model is in the same way that you would expect your output to be as well. You can't be laggy with it and give it in any kind of input or output. You have to be very, very clear when you're doing this in terms of garbage and garbage. Okay. So now coming back to the main question, why do you have to split your data? Why is it important? So the goal is to evaluate your machine learning model which you've created on unseen data, data which has not been created. That's very, very important, right? So that you understand whether the model is able to generalize and work on all kinds of data or not. Now, why do we do the train test split? Okay. Train test split helps you to prevent three major things. One is it prevents overfitting. So what is overfitting? We will look at it. Overfitting is basically when the accuracy or the performance of your training data is much more greater than the testing data. So which means that the data that you fed to your model in the beginning, your 80% or whatever split that you've taken of your data, whenever you fed that to the model, that accuracy is way more than the testing data accuracy, which you will see on the unseen data, right? So that is something which you will need to evaluate. Okay, that is one thing. Secondly, what does train test split help you to do? It helps you to get a realistic accuracy. So when you say realistic accuracy, it means that it's close to normal. Okay, so when you say close to normal, what it means that it's general, like it's status quo, more in normalcy, how could it really go ahead? So get your realistic accuracy is very, very important so that you can actually use this model in production or wherever you need it. And third is validate generalization. So if your model is going to generalize well, you can use it in any production environment very, very comfortably. So you can just think of your test set as nothing but a final exam, but not a practice quiz. So it's not like your practice quiz, but like your final exam where your testing is being done. And then your outcome is something that you will use further, right? Like in your 10th exams, you give your papers and you got certain marks, percentage, and that is what you used further, right? Like to gain admission into your 11th standard, 12th standard, and so on. I mean, further on. And 10th standard marks are percentage is something which is used throughout your life, right? So that is something which is very, very important. So that is how you have to keep your perspective as think about it in a generalized manner. So that's why splitting of data is very, very important. Now, how do you use this train test split in scikit-learn, your sklearn library that you've seen? Now, this is the syntax for it. That is, you use the library from sklearn.model selection, import train test split, which is the function which you'll be using. Now, here you divide it into 4 different sets, as you can see: xtrain, xtest, ytrain, and ytest. Because you've divided your data set into 2 parts yesterday, right? X and Y. So you will divide this, create this, and then call your train test split function. To which, what is the input that you will give to the train test split function? X, which is your features, and Y, which is your target variable, where your test size is 0.2. When you say test size is 0.2, it means that 20% of your data is going to be your test data. 80% of your data will be your training data in this case. And you mentioned a random state which is equal to 42. 42 is nothing but a random variable which ensures reproducibility, which means that the same train and test set will be created when you give 42 as a random state over there. Now you need to remember one single rule while you are trying to train. That is, you should always split before training, not after training. So keep that in mind. Okay, that you split your data before training and not after training. All right. We'll do this code, don't worry. I'm just trying to showcase and show you what really we are trying to do via this train test split so that you understand what is going to be happening at the back end. Okay. Now you can see that 20% is your test data set and 80% is your training set, right? Very clearly you can see all of this, which is nothing but your data distribution in your machine learning model. Correct? Now this is your train test split. Now let's go to our code and try to use this. So we saw this code yesterday. Does everybody have the code file? Like we had used this code file, right? Yesterday. Does everybody remember the code file that you created where you tried to import the data set and you created this X and Y variables? Do you all remember? Can anybody type on the chat if you all have the file in front of you? Yes, I can see a few people, 2 people saying yes. I want more people to say yes. There are a lot of people on the call, so I just want all of them to, say yes. Loading, yeah, that's fine. Loading, mine is also loaded. You can see it's connected. So now what we can do is next, like we created the model, and we did the predictions and so on, right? Now below this only we will do the train test split. Okay. So for train test split, The code that we will be using is going to be this, which is nothing but your train test split code. So we will just create an 80-20 split between our data and use that, right? So now we just put this x underscore train, comma x underscore test, comma y underscore train, y underscore test equals to train test split x, y, and then you mention your test size is 0.2 and random underscore state. So basically we need to import this. That's why it's given me this error. And since I've reconnected, I will also need my x and y variables. So I'm just going to execute this to load it. I'm just going to execute all the commands that we had given before to load the data set. And we have x and y here. And we have x here. And we have y here, which you have seen before. This is all code from yesterday, so you don't have to worry. All those of you who has attended the day one bootcamp remembers all of this, where we created x and y, right? Now what we'll do is we'll create the train test split. Now we'll just have to import it before that. So when you want to import this before that, what you really need to do is use that library that we mentioned, right? From sklearn.model selection. You just say from sklearn.model underscore selection. And then what you'll do is you'll do import train test split. So you have all the 4 variables over here now. Now when you print this, I know that everybody wants to copy this, so it's right here on the screen. So X train is looking like this. We'll be able to see the shape of it. So the original shape had some 150 records, and now it is 120, because we said that 80% will be the training data and the rest 20% will be the testing data. Is everybody done with this much? Any questions for train test split? Everybody is good with this train test split. We've just done this much till now, just the train test split. We'll go ahead and learn about the data pre-processing and all also. Any questions still here? Awaiting any questions that you would have, please put them down on the chat window so that I can assist you. No questions? Okay, fine. Let's move ahead then. So this was the train test split, right? Now we'll move to handling missing values. So if there are any missing values in your data, which is a normal case, right? Like say many a times you register on these OTT platforms. How many of us would have accounts on like say Hotstar or Sony Live or Z5 or Netflix and so on, right? Do we fill in all the form fields which are given to us? No, right? We often leave them, the ones which are not mandatory, we tend to leave them. So real world data often has missing values, correct? Nans, right? Not a number. Nans are nothing but not a number, which is null values, right? That is quite possible. Real world data will always have them. But the issue is that ML models can't work with them directly. That's the case. Like ML models can only work with complete data that is complete, right? So it can't work with them directly. So now there are ways to drop certain rows if you have missing values. And you can also fill those values, like if there are null values or null values, you can even fill them. So to be able to do that, we have these 2 functions which you can see on the screen. df.dropNA and df.fillNA. So dropNA will drop those rows which have null values, any values, and fill NA will fill those values with certain numbers. Now say if I have 6 students and I have their ages mentioned. But for the 6th student, I don't have the age. Like, the student has not entered the age. Then in that case, what will you do? You'll have to fill that any value, fill that blank cell in your data with what? Average of the ages. Would that be a good metric to consider? Anybody? If somebody knows, is average a good metric to consider if you want to replace that blank value? Yes, it is, right? I mean, like, if I had to fill in the age of all the students and they are 8, 9, 10 years of age. Now, if I don't know the age of a certain student, I can always fill it with the average value, right? Because that itself would be a good indicator which will tell that, okay, this is representative of the population itself, right? So that's the reason why I can use average or median to really replace those null values which are there in our data. And we would need to do that, right? Because what will happen is ML models can't take in blank cells. It will give you an error. Straight away the model will tell you that, okay, this is not something that I can work with. You need to give me complete data. So it will very explicitly tell you all of that. Okay. So now how do we handle these missing values? There are codes which help you to do that. Okay. So one is fill NA, as you can see. So it's df.fill_NA. That is the function which you can use, and you can replace it with df.e. And in place equals to true means that it's going to replace it here itself. You don't need to store this in a separate variable. Okay. So you can use this to fill all your NA values. Now, if there are any values which are very few and you can drop them, you can just delete them from your data and it will work fine, then you can go ahead with that as well. So for that, the code is df.drop_NA in place equals to true. Okay, so this is the code for it. Now, what is the strategy that you should choose? Choose a strategy based on your data set size and domain. Okay, so based on how much data is missing, and whether that data is very important for the system or for the use case or not. That is very, very important. So that is the major thing which you should focus on. That is choosing the right strategy to replace the missing values that you have. Okay. So that's exactly what you should keep in mind while you are trying to deal with missing values. So that is one aspect, missing values. The other aspect, the other issue that we said, right, like where certain data is in a different range, like age is between 0 to 80, right? Whereas height is in centimeters, and whereas salary is in rupees. So in this case, what do you see? That the range is very different for each of the features. Now, certain algorithms are very sensitive to scale. When we say algorithms, these are machine learning algorithms. Okay. Um, so some models like SVM is support vector machine or KNN is k nearest neighbors. These algorithms are specifically very sensitive to scale. So which means if you give your age, your height and your salary as is to the model, it will give you issues. It will throw out errors. It will say that I cannot work with this. It will give you those errors. So in this case, what is the problem? That these models are sensitive to scale. So you need to ensure that you are doing scaling and normalization. So scaling will bring all your features to the same range. There is a formula, there is an equation, which is used for every kind of a scaling mechanism that you'll be using. So you'll just bring down the age between say 0 to 20, your salary between 0 to 20, and even your height between 0 to 20. Just an example. It's a random example just to give you an idea of what we are talking about when we say scaling and normalization. Now, these are the two different types of scaling mechanisms. One is min-max scaling, second is standardization. So in min-max scaling, the output range is 0 to 1, which means the data is scaled down, the values are scaled down to between 0 to 1. Whereas standardization, the mean is 0 and standard deviation is. This is a good example of what? This is a good example of normal distribution, something that you would have studied in class 12th or somewhere, right? I'm not sure whether where you would have learned about normal distribution, but it would definitely have come to your syllabus somewhere or the other, somewhere definitely. So min-max scaling and standardization. Now min-max scaling is very good for neural networks, whereas standardization is great for SVM, support vector machine, or principal component analysis, which is PC. These are algorithms which are used as a part of the machine learning framework. This is just to give you an idea about how scaling looks like and what you can really do as a part and parcel of this. Okay, now let's talk about how to really implement this. So of course, we already have scikit-learn implementations for this, so you don't have to worry at all. So what are the implementations? You can import them directly from the sklearn.preprocessing package and then use scalar equals to standard scalar. So you're just initializing the scaling mechanism here. And then once you've created this object, you will use fit underscore transform on top of this. So you'll say scalar.fit underscore transform x, and that will be stored in x underscore scale. Okay. Next, what you have is from sklearn.preprocessing. Input min max scale. And in a similar way, you create an object and then you do fit underscore transform on top of it to store the output in a particular way. Right? So this is how you can scale your data. So we will still see this practically in from code perspective, where we apply your drop NA as well as your scaling on your iris data set. Okay, before we move to the next one. So what we'll do is we will do this in code. So while we do this in code, what we'll try to do is, first of all, let's try to do drop NA, right? So that would be an easier thing to do, correct? So when we say drop NA, we'll just look at the data frame. So these are things which you can always do before you're splitting. Because when you do all of this before you're splitting, you can do this on one chunk of data. Else you will have to apply this on different pieces. So when you created this iris model, right? Iris data set here, and you divided it into x and y. So you see x and y. Now iris dot drop NA in place equals to true. Which means what will this do? If there are any values in my data set, it will drop it. Now how do I check the output? You can always check the shape of the data frame, right? And when you do that, you will see that it's unaltered. Prior to running this command, it was 150 into 5. And post running this is also, it's also 150 into 5. So which means it did not find any values in my data. So it has not dropped anything right now. Okay. So that is also very important for you to know that, okay, what is really happening. So drop NA is something which you are doing to get rid of all the null values. Okay. Now, if there were null values, then you would do fill in. Now, since there are no null values, you will not do fill in. But you can do scaling and normalization. So if you see this data, like if you look at sample length, it's 5.1, 6.2, 5.9. This is the range of the data. So I want to bring all of this into a standardized range. So this is 0.2, 1.9. These are slightly smaller numbers in comparison to the other. So if you want to bring all of this to a standardized format by doing scaling and normalization, what you can do is you can apply your scaling and normalization. Now, which one we should apply? We can apply, so since this is nothing but a usual, data set which does not have neural networks or anything, we can do standardization. So say mean equals to 0 and standard deviation equals to 1. So we'll do that. So if we want to do that, we'll say from sklearn dot preprocessing import standard scalar. And then what you say is scalar equals to standard scalar. So you've defined the object for standard scalar, right? Everybody is able to see this. how we are able to do this. Now we'll have to store this in a new variable, right? Because it's a scaled out, correct? So that's how it's storing it over here. So which method do you use as a part of this object? Scalar.fit transform. And you apply that on your x, which is your features without your target variable. That is over here it is sepal length, sepal width, petal length and petal width, right? Like as we've seen above, our x is nothing but your sepal length, sepal width, petal length and petal width. So we'll apply on this to standard scale your data. Now let me go to that and execute this to show you what it would have really done. Now let's look at x underscore scale. You can see that it has created an array of all of these different features with 4 values each, right? 1, 2, 3, 4, 5. Correct? Any doubts still here? We've covered two major concepts. Why do we do train, test, split? And secondly, how do you do it? And secondly, how do you do scaling and normalization? Any doubt in here? Oops. Just type it on the chat window so that I know that you guys are following it. Yes, we're following, we're not following. If it's throwing error, it would be most likely a syntactical error. So it's better if you look at the code so that you're not writing anything wrong. Everybody understood till here? I should explain scaling again. So what do you observe with the output when you look at the scaling output? The numbers have changed, right? Why have the numbers changed? Because they have been brought into a certain range where the mean is 0 and the standard deviation is 1, which is nothing but converting your data to normal distribution. So when you do that, there are changes. Okay. So the prompt, I don't have a prompt, I have a code. So we've not written any prompts here, we've written code. No, the range is not 0 to 1. It is having a mean of 0 and a standard deviation of. So the values can be anything between minus infinity to infinity, but it should have a mean of 0. That is what is very, very important when you talk about standard scalar, which we have applied. Range has to be 0 to 1 in the other scalar that we were talking about. We spoke about another scalar also, right? Like the min-max scale. Yes, I can share the collab link with you folks. I will put that in the description box if that works with you guys. Gemini fixed it, guys. Please don't use AI for this. Try and work with things on your own rather than using AI, please. So that you know what is really happening. That's very, very important for you to know. I'm just going to put it on the description box. You have this documentation below, right? So that's where I'll put it. You all wanted to collaborate, link outright, right? So that's why. Putting that. You will get the link, so don't worry. For now, just try to follow this as is so that you are able to understand. Okay. Because otherwise you'll just get lost in this entire process as to where the code is and this and that. So I don't want you to do that. I want you to focus. So it'll be just better. Just check that the syntax is clearly written, and that will help you solve your issue, whatever your issues. Okay. Now let's move to the next module. Our next module is all about training as well as evaluation. You'll be able to fix the error, don't worry, because the collab link will come to you today, post the session. Okay. So we'll learn about model training and evaluation. The first thing is training versus testing, what and why. So the why part of the answer is something that we'll answer in detail here. Secondly, we look at the metrics. What kind of metrics are used? Like a quick overview about what is accuracy, what is precision, what is recall, what is F1 score, and so on. What is the confusion matrix? How do you really read it? And how do you evaluate your model using model.score and classification underscore input? So we'll do all of this. Now, what is model training and testing? We did speak about this, right? Like, what is it that is okay, I did not. So these were the 4 points of all the module 2 that we'll be looking at: training versus testing, the metrics overview, the confusion matrix, as well as the evaluation component, right? So there is a question in the chat where somebody is asking me, why are we using scaling if you're using tested framework? This was just for demonstration purpose. I just showed you how you do the scaling on data, but it's not necessary for you to do it for decision tree model. So I've just shown you how it looks like. I wanted to display the output to you, so that's the reason why I've done so. Else it's not required if you're doing a decision tree model. If you're using linear regression or logistic regression, that's where you will need the model and the details around it, the scaling, the pre-processing, and everything. Back to your module 2. So what is model training and testing? So training is nothing but your model learns patterns from your labeled data. Whereas what is testing? Model is evaluated on unseen data, right? We already spoke about this, that the labeled data is nothing but something which is used for your training. Whereas model that is evaluated on unseen data is for testing. So what does this do? It ensures that the model isn't just memorizing. So you as students, you guys do, stick to rote learning, right? Like you just keep saying the same thing again and again, and it is memorized in your brains. So if you want to, just get rid of that, we are doing model training and testing. That is, we change the data so that you're just not applying the model will not just apply its memorization techniques over here. So you train on your past data, but you test on your future life data. So yesterday we were talking about this weather prediction model, right? So whenever you're trying to build something like that, you will be using the historical data from the past 5-6 years. And when you're trying to, predict, what you will do is you will try to predict it on the most current data or the next 5 days, what the weather could really look like, right? That is also possible, right? So that is something which is very, very important, so that you come to know whether the model is cheating or whether the model has genuinely learned. Okay. So now let's talk about why you should not evaluate your models. That is, you should not get your performance metrics, the report card for your model on the training data itself. Why? Because models may overfit. So we were talking about this concept of overfitting, right? That is, it's too good on training, but very bad on test. That is, your training accuracy, your training performance is far greater than your test data performance. It's more like revisiting your past papers. Like you look at your past papers, your unit test papers, and you did well there, but you failed in the final exam. So that's exactly the reason why we should not evaluate the model of the training data. So what is the key to this? Generalization is the major key to your real world performance as to how it can work better and how you can really generalize and do much, much better on your training data itself. Okay. So that is one major important thing as to why you should not evaluate on training data. This you should remember this always. Do not do this in your office when you go and work in the industry. Now, what are the different metrics that we can use to evaluate our machine learning? First is accuracy. Second, that you can see over here, is precision. Third is recall, and F1. Now, what is accuracy? Overall percentage correct predictions. So with the correct predictions, if I have predicted 80 out of 80 predictions correctly, out of my correct predictions, then that's 100% accuracy. 80 on 80 would be 100% accuracy, right? Everything is correct. It is very good for balanced classes, wherever you have balance maintained. Now, what is precision? So, of the positive values that you predicted, that is 80 values that you predicted, like for the next 80 days, what is the weather? Whatever is predicted and what you see on Google is absolutely correct. Whatever is being predicted as positive, how many were correct out of that? So, it's not quite likely that things would be 100% accurate or correct. Okay. Why could that be the case? Because you will see that weather is highly influenced by way many factors, and climate change and whatnot is actually affecting it today. So when we see such a scenario, you can see that the results that we'll be getting when you try to test it, it is not going to be 100% correct. So precision is nothing but of all the positives that you predicted, how many were correct. And in recall, out of the positives that you predicted, like the actual positives which were there, how many have you got? So why do you do this? You do this so that you can actually catch frauds. So there are a lot of frauds that happen in the cyber industry, right, today. Like all of us use net banking or Google Pay. When you use that, many a times people fraud you, right? There are links which you click and you may lose money. Cyber fraud. How does that happen? Because the links that you click are seemingly real and you click on it. But when you click on it, you get caught. You get caught in that entire process because you have not ensured that you are keeping track of what is correct and what is not. Right? So that is your rigor. That is from your positive values, the actual positives, how many were caught correctly. So that is very good for fraud detection as well as cancer study. Because for cancer, you cannot have wrong predictions. If somebody who does not have cancer has been detected as having cancer, that can cause a lot of health catastrophe, right? Because you might be given heavy medicines, radiations, and so on, whatnot that comes along with the cancer treatment, right? So while all of this is being done, you need to ensure that your prediction is bang on. It has to be correct, right? So that is very important. So that is where recall becomes a much more important factor in comparison to precision. Because precision is going to work on the predicted positive values. And now what is F1 score? It is a good balance between precision and recall. Where is it useful? For imbalanced classes. So when you see in the workforce out today, right, many distributions are very biased. That is, you have in IT companies also, we do not have 50% of women in the industry yet. We may not even have 30% in a lot of cases. So what is this? This is nothing but bias, imbalanced classes. So when we are working with imbalanced classes data, we should see that we are using a good performance metric for it. Something that is relevant for it. So something like, say, this one which you see, which is nothing but your F1. So F1 score becomes a good balancing factor at that point, right? So that's exactly what we are really talking about here when we talk about the different metrics that we. Okay. Any questions that you have, put them down in the chat window. I'll answer them once we complete this. Okay. Now, balancing your precision and recall is very important for optimal model performance. So, if you have a precision focused model, right, where you will prioritize accuracy, where you will try to minimize your false positives. So, have you guys all heard about true positives, false negatives, and true negatives? We'll look at that concept in the next slide because that is a good representation in the form of a confusion matrix. How many of you folks have seen a confusion matrix before? You can just give me like a yes or no if you know about the confusion matrix, or if you've heard about what is true positive, false positive, true negative, or false negatives. That would just help me to understand. Nobody's replied. Nobody has seen or understood or read about true positives, true negatives, and all of that. Are you serious that you've not? heard about it? Nobody has replied, yes, ma'am, not read. Okay. I don't see that anybody else has read, so we'll look at it in detail. That's fine. So you can always have, okay, so you can always have your predictions in such a manner. That is, this is your confusion matrix. And what is it? Basically, you're trying to balance accuracy as well as error in your predictions. So you can have only 4 cases. That is, this is your true positive rate, this is your false negative rate, true negative rate, and false positive rate. Okay, so these are your predicted positives and these are your predictive negatives. Now, what are your true positives? Which is TP, FP, FN, and TA. These are short forms. True negative, FP, false positive, false negative. So true positive is model got it right and it matters. So say for example, I went for a biopsy report and I'm trying to check whether I have cancer or not, whether the tumor that has been detected in my body has cancer or not. It's a healthcare scenario. It's a very typical scenario, a very regular scenario where people go for checkups and they try to check this, right, on a day-to-day basis. So now over here, if I have cancer, like the model has predicted it, and that's actually the case. That is, the model got it right. That okay, I have cancer and has predicted it correctly. So that's where it becomes a true positive, a T. Now the model said yes. The model says that I have cancer, but I don't have cancer. And if that's the case, then it's a false positive, which means that the model has wrongly predicted me to be having cancer, which would be highly malignant, right? It could prove to be deadly as well, right? It can be anything. I mean, it could go via the any routes when we say that it's a false positive. Now you have true negatives also. That is, I don't have cancer. Okay, that is the reality, and the reports, the model which has been used also says that that I don't have cancer. So it's a no and a no from both the sides. Then it's a true negative, which means that it is a negative case, that is, I don't have cancer, but the model has predicted the negative case correctly. So in this case, it becomes a true negative, right? So this is what is the best representation of what is a true negative case. Now, what is a false negative? Something that we did not speak about at that point of time. That is, model missed something important. That is, I don't have cancer, but the model predicted saying that I do have cancer. So, what happens over there? What really happens? It is a false negative. That is, I don't have cancer, but still it is predicted. Right? So, it becomes a false negative, saying that, no, sorry, that was false positive. So, false negative is more like it's actually not there, I don't have cancer, and it has predicted that I have cancer, which is correct. That is exactly what I said. False negative becomes that kind of a scenario. So these are the, you can say, the basics. You have ABCD when you're trying to learn the English language, which is the basic fundamentals in any language. So here in machine learning, the basics are the confusion matrix. And it becomes a very, very important aspect of with respect to learning, with respect to understanding all of this behind model training, model performance, and all of this, right? So you need to ensure that you are very, very well aware of these 4 terms in the machine learning context. I will give you all the PPTs as well as the collab file with to you post the class in your documentation. I will pass it on to the LetsUpgrade team and they will pass it on to you. So don't worry about it. All those of you are worried about that in the chat. So this is a very important concept. Keep this in your mind. Or when you go to any interview, make sure that you have revised this and you have not forgotten about what this is. Okay, just remember these golden words and you will always thank me throughout your life, because in all interviews where you are trying to explore data science and AI, confusion matrix questions are bound. Okay. So this is about the confusion matrix. Now, how do we really calculate the model's accuracy and the model's confusion matrix and so on? So there is a function model.score which lets you use the test data. Of course, we'll be predicting on test data, so X test and Y test. You calculate the accuracy and then you print that accuracy over here. That accuracy. And then you say you can get the confusion matrix also via the classification. So how can you do that? You can do that by using from sklearn.metrics import classification report. That is a good way to import the classification report. And then what you do is you can just import that and then print the classification report by passing it the y-test values as well as the y-pred values. Y-test and y-pred is nothing but your testing data that you have and the predictions associated with it. So this is exactly what is your model score and accuracy. We will do this on code now so that you get a good enough idea about what is happening. Okay, fine. Let me just go to code and let's print. So we already have the model, right? We had the decision tree model. We do have the predictions and all. This is not executed. Make sure that you've executed yesterday's code so that you have your model.fit here and you have the predictions and all. But now today what we've used is xtrain and xtest, right? So after we've done this, what we can do is we can do model.fit again. So you can just copy the model.fit statement which is there over here. Model.fit. Now over here, instead of x and y, you can just place x underscore train and y underscore train. So you fit a decision tree classify over here. Now if you want accuracy, you can just say model.score and you can paste x underscore test and y underscore test. So it's giving me an accuracy of 1, which means 100% accuracy, which usually is not the case. Here the data set is very idealistic, it's clean and it's used for learning purpose. So that's why you would see an accuracy of 100%. You will never see an accuracy of 100% otherwise. In any case where you're working with any kind of data and whatever you're doing associated, okay, that will always be the case. Now, if you want to print the classification report, you can just say print classification underscore report and you pass to it the test data, x underscore test, which are my features and my labels. To import this, right? From sklearn.metrics import classification. Can't handle a mix of continuous multi-output and multi-class targets. Okay, x underscore test. If you look at it, continuous values, y underscore test is also y underscore test associates, right? So now the error that you see over here, it's saying that classification metrics can't handle a mix of continuous multi-output and multi-class targets. So what does this mean? Anybody has any idea about this as to how we debug these things? Because coding or learning about things is not just building, but also to be able to solve any doubts or any problems that come your way, right? Because that is bound to happen. You will always get like n number of doubts also and hurdles also while you're trying to solve the problem, correct? So has anybody tried to solve this? Then there is a method to do this. You have Gemini who can do this for you. So you can just say explain error and it will open up Gemini over here for you. So you can see that it's working. It will tell you what exactly the error is. It will tell you how to really go ahead and get this working. That is also very important. So it has given me a correction. So for predictions, I did not use model.test, x underscore test. So you need to use x underscore. Now, if you look at the classification report, the changes that it has made is when you're doing model.predict, you need to ensure that you are predicting it on x underscore test. And now when you try to print the classification report, which is this one, you can see that it has put y underscore test and the predictions here. So you don't have to directly put the x test and y test here. Here you need to put two values. First is your y test, which is nothing but your actual test labels, and here what you have is nothing but your predictions. So what kind of predictions are there, what you've been able to create by using model.predict, which we saw yesterday, right? So on the basis of that only we have done this and got the classification report. Now in this classification report, there are multiple things which you can see. Precision for each and every class, like Setosa, the precision is this, recall, F1 score. The major things that you will be concerned about in the confusion matrix is going to be this 3 into 3 matrix. Precision, recall and F1 score for all the different classes. This is how you usually tend to go from start of the data set to model building, which is very, very important, right? So this is how you interpret, and this is how you get to know that, okay, this is all 100% accuracy. It's giving me a precision of 111. Great. Recall is also great. I can just move ahead and work with this, right? So it's giving you optimism. It's telling you that you can go ahead and try to work with this model in the real world setting, right? What do you want me to repeat code with Akash? Okay, he's saying that I should repeat this. So, okay. So this precision, recall and F1 score, are we clear with those concepts, everyone? We learned about these concepts, right? So we're good with this. Are we all good? Yes, no. What is precision? What does it help you to do? It helps you to predict which ones are correct from the predictive positives, right? Right? That is one. Number two, what we'll do is recall. What is recall? Recall is predicting the actual positives, like which ones are predicted actually correctly from the positive values setting. Right? So that is one thing that should be emphasized upon, should be understood really well, right? So this is how you would interpret your classification report. I will answer the questions which are there in the chat window, don't worry about it. But is this concept clear with everybody with respect to classification report, which is going to print the, calculate the precision, recall and F1 score and bring it in front of you? Is this clear with everybody? Yes, no? Give me some idea around it, whether you've understood or not. Others, I am still here. I barely see anybody responding with a yes or a no. If you all don't tell me yes or no, how will I come to know whether you all have understood or not? Or if you feel that there is some confusion, you can revisit the recording later to hear the example, to hear the concepts and see whether you are able to understand it or not. And if there are doubts, you can then ask me tomorrow, later, whatever. Okay. So now I'll take the other questions at the end, the ones which are not related to this module. I'll take all of them at the end. So don't worry if your question is unanswered. Okay. So now we go to module 3. So till now you've seen some predictions. You saw accuracy score. You saw scaling. You saw train test split. You saw all these 4 concepts. Now, if you want to improve your predictions, what do? You try different models, right? So you go for KNN, which is K nearest neighbors, or logistic regression. Then you compare your model using your accuracy scores. How you can really, go ahead and compare them on the basis of their accuracy scores. And then we'll understand the concept of overfitting and underfitting visually. So how it's really affecting things. What changes when we try to look at overfitting and underfitting from a visual perspective. Okay. So why should you try different models? That should be a genuine question that anybody would have. No one model is going to fit all ML, right? All and everything in ML. Each model will have its own strengths. There are different strengths. So you should choose the model that perfectly fits your data. It fits the best on your data. So whenever you're trying to do machine learning, just keep in mind that experimentation is going to be the key. That is, you should be able to try multiple models and see which one works best for you. You should know about that. That is, you should be able to experiment. That's very, very important. Okay. Now, which was the first model that we used? Everybody remembers decision tree classifier that we studied about yesterday. It is simple and fast, right? Quite simple and fast. But is it the best? It's not, right? Is it the best? No, it's not. We'll find out. I mean, let's not just even say yes or no. Let's just find that out. How can we find that out? We'll be trying new models. Okay. The two different models that we'll be trying now is k nearest neighbors and logistic regression. So k nearest neighbors is a very, very simple algorithm which works on the neighboring concept. So if I am situated here on a particular center point, the neighbors closer to me, so the points on the axis which are closer to me, will also have similar classification, similar predictions. So that's the basic logic which it has. K nearest neighbor. Very simple. It works really well with small data. And the second one is logistic regression. The logistic regression model is a regression model which is based on a little bit of mathematical concepts. It's based on a sigmoid curve. So where the predictions are something which are based on an S curve, and where we use the logit function, logODS function, to really calculate your loss, to calculate your data tendencies and everything. So that's what these models are: k nearest neighbors and logistic regression major, to be able to help us do things. So whenever you're trying to do a classification use case, where you're trying to predict whether it's a cat or a dog, or whether you're trying to predict which flower category does this data belong to, you should start with logistic regression because it's the most baseline model, the most reliable model on which you can rely on. Now, what is k nearest neighbors? It looks at the k closest points to make a prediction, as I said, right? Like I'm here, my neighbors may be sitting here, the one who is closest to me, same kind of attribute will be sharing. So it's like peer voting. So whatever is the prediction for that class should be the same one for me as well. So that's how it is k neighbors classifier. And this is the code for it. From sklearn.neighbors import k neighbors classifier. We will be using this. Okay. Next is your logistic regression model. So despite its name, it's going to be used for classification, and it also predicts the classification for the different classes that you have. It will predict a probability. Now, on the basis of the probability for every class, it is something which is going to be judged on the basis of a sigmoid function, which is an S curve, a sigmoid function. And it works very well with linearly separable data, okay? Data which is separable. Something that is separable is what is used here in logistic regression. And this is the, you can say, the code for it. That is from sklearn.linear model import logistic regression. This is what is used to create a logistic regression primarily. Then what we will do is we'll compare these models. And this is the code for it. So how do we really compare these models? We'll compare decision tree, KNN and logistic regression. All of them in our code. And then we'll see the accuracy for it. Okay, and then we'll have an accuracy comparison chart. So before we go to the accuracy comparison chart, let's just look at the code. Let's create a comparison chart where we compare the accuracies for all the models that we have. Okay, so that we are in a position to comment that okay, this particular model is better or which one is better, and so on. Right. So let's just define our models, where what you can do is you can just say models equals to decision tree, and then you mention decision tree classifier, k nearest neighbors, k neighbors classifier, and logistic regression colon logistic regression. So here we've created a dictionary basically, where we will first import all the models. We'll have to import because otherwise otherwise it will give you an error that the model does not exist. Right? So you have to ensure that you have written your import statements prior to doing this. So from sklearn.neighbors, import a neighbors classifier, and from sklearn.linear model, import logistic regression. So we've defined these three models and we have created the import statements for it. Right? We've done this much. Now, once we are done with the model creation itself, then the next step is to calculate the scores. So while we do this, we'll just write for name comma models. We are iterating over this dictionary that we've created. So for name comma model, sorry, in model items, and then it's given me a prompt directly. We can use that prompt or not, totally up to us, but we have to do model.fit x train and y train, which is very, very important for us. And then you can have the accuracy for it associated, like you just have the accuracy where it's going to calculate the model.score, and it has just formatted it to 2 decimals. So it is showing it in the form of percentage. So now when you see this, it's going to show me that all the 3 models are giving me 100% accuracy for each of the models. Now, why do you think this is happening? What could be the reasons for my model accuracy to be only 100% for each of the cases? This should ideally not be the case, right? Why should it be 100% for each of the cases? It should not be, right? Can somebody tell me on chat, why do you think the model accuracy is 100%? Does anybody have any clue as to why this is 100%? Okay, I'll tell you the reason. So the data that we are working on, right, the iris data set is a very small data set. It's just 150 records. So whenever it has just 150 records, what will happen is it cannot really, distinguish or do anything with respect to the predictions. So that's exactly what I'm talking about. That is, the training and testing data is so small right now that you cannot just work with it immediately with such small data, and it will not give you these kind of predictions. So it's able to understand the patterns and give you the best outputs here. But this will not be the case when your data is going to be larger. Now, since we are using this for demonstration purpose, right? When we use a smaller data sets, it's easy for you to understand and correlate. But if I use a very big data set, say like 10,000 records or even 1 lakh records, what will happen? It will become very difficult to relate to. It will become very, very difficult to be able to even, comprehend what is happening at every stage. The scaling output is also something that will make you go lost. So all of these things considered, we take a smaller data set into consideration. And that's how we get these kind of, outputs that you can see out. Can you see my screen now? Is the PPT visible? Yeah. So everybody is pretty much understood this, what is really happening with respect to the different models and how they are really giving me results. It will not be the case that all the models will give me the same results. So as you can see in this example over here, since the data that has been considered is different, you will see that the values are also different. You can see that decision tree is at 0.93, which is 93%. KNN is at 0.96, which is 96%. Logistic regression is 95%. So in this case, KNN is performing the best, whereas the other two, decision tree and logistic regression, are not able to perform really well, right? Now we'll go to one last topic before we complete today's class. So here, what we'll try to understand is what is overfitting and underfitting. So in underfitting, the model is too simple and it misses the patterns. So the model itself can't, understand anything, can't understand any patterns. That is the case. And with respect to overfitting, what is happening? Model is too complex. It memorizes the data in certain aspects, but it can't remember everything. It's going to get lost in the process, right? So you need to have a good fit, which is the right balance, which is going to generalize well between overfitting and underfitting. That is, your model should be able to generalize really, really well with the data that you are working with. So that is exactly what is dealing with your overfitting as well as underfitting in a lot of ways. So you need to ensure that the model that you're using is not falling prey to overfitting or underfitting in any way. Okay, so if you see this kind of a visual will give you a very good understanding of what underfitting and overfitting is. So as you can see in this example, on the left hand side, there are circles and there are crosses. So which means there are two different classes, right? Now in this, you can see that there is a straight line which has been created, which is your model prediction. Now this straight line itself tells you that, okay, you can see that three circles have been misclassified as crosses, right, on the left hand side. And on the right hand side, there are some crosses which have been misclassified to go on the circular side. So you can see that it has drawn a straight line. And the straight line is not going to be able to differentiate between both the classes. It is impossible to be a differentiator or classifier in this case. So here you can see that it's underfitting. That is, the model is very simple. It has two classes and it has a clear boundary. But still, it does not recognize the patterns properly. That is what is the case. Now, when we move to the right hand side, what you see on the right hand side is that there is a curved boundary which is going all over and which is creating like a proper demarcation line between the circles as well as the crosses, which are the two different classes that we have. So here you can see that the line which is being drawn is a good enough representation of how training and testing data should really look like. So here you see that the training data is able to understand the patterns really well. It is a little bit complex, right? Because if you see the patterns itself, it's able to, do it properly, like do the division and all properly. But when it will be subjected to new data, unseen data, new testing data, it might fail. So overfitting is exactly that problem that you might come across, where you will see a scenario of the model failing, the model not being able to cope up because of the patterns that it has, which are nothing but complex patterns. So now you'll be wondering, what would be the right fit between the two? Because I have a lot of overfitting, I have underfitting, what do I do? So the main question that should come to your mind is, how do I choose the best model, right? That is very, very important for you to know, correct? So whenever you want to choose the best model, you should check the test accuracy. That is a number one rule, right? You should always check for your test accuracy, how the model is performing. Then look out for overfitting. Check the graph. Check the performance of the model. You'll see that the predictions are going here and there, and whether it's a straight line model, whether it's able to work with the different things or not. All of that is something which you will see. You will observe overfitting. Now, when you see these two things, when you check your test accuracy as well as the overfitting scenario, you should choose the simplest model that performs well. You should not go for more features. If there are more features, it's not necessarily the case that you will get a better model. It's never the case. I mean, you don't have to go by it that somebody has told you that more features means better model. That's not at all the case. Okay. So this is how you can really go ahead and choose your best model. So yeah, this pretty much brings us to an end of this session today. I would suggest you to practice. So this collab link is something which I will get it shared via the Let's Upgrade team with you all. You all try these three different models on the Iris data set. Use your model score to compare and see which one performed the best. When you try it in a different way, with your scale data, you train it on that and then you test it on your test data, you will see the difference. So model score will not always be one. So you do this entire activity and let me know which model performs the best and why accordingly. So that I know that you've gotten a good enough understanding of how things work. Alright. So now we'll open it up to questions. First of all, I'll answer those questions which I have missed from the chat earlier. Let me just see. Somebody had said, yeah, we can build a model which can detect people's mental health and stress by chatting with them because these people have nobody to talk with. So it will be really helpful. Yes, code with Akash, that makes complete sense. It will be very, very useful if you can build such a model which will be used for mentally ill people because they do really need somebody to talk. So it makes sense. Somebody has asked me, will we only use sklearn data sets in this bootcamp? How do we use data from websites or APIs? Because I think sklearn data sets will almost always give 100% score. That's correct. So for demo purpose, we use sklearn data sets because it's something that you can work with in the time frame that you have. Since this is like a 90 minutes bootcamp, right? Like for every day. So for you to be able to see the outputs and for the processes to run, it makes more sense to show smaller data sets. While I agree that to be able to fetch data from websites or APIs, so we'll keep a separate bootcamp for it, which will cater to this. That is, be able to fetch data, to be able to scrape data, to be able to create data sets. So we'll try to do a separate bootcamp for that. I'll definitely convey this to the LetsUpgrade team because it will be a good add-on for everybody to understand it. Yeah, guys, keep asking your questions because I am going to answer all of them right now. There are few chunks of doubt lying here and there. According to a module, can we create a model like these for translation conversation? Yes, you can create a model like this, Sami, and it's pretty much doable. You will have to just pick up data from Kaggle or Google. You will have to see that the data is available or not, and you can train your model. So low bias is underfitting and high bias is overfitting. Yeah, in a lot of ways that is correct. Interpretation is correct. When will you share the collab link? So I will share the collab link with the LetsUpgrade team and they will update it on the all documents link which is present in the description bar of your YouTube video, the day video that you have. So you will get it over there. Can you please explain prediction part in short? I can explain that. So what we are trying to do is we are trying to train a model and then get predictions. So the best example in this case would be something where you would see that you are trying to predict for weather, like you're trying to predict the temperature for the next 5 days. When you're trying to do that, what are you saying? You're taking the historical data into consideration, right, for the previous days, and you will predict on the basis of that, right? So those are nothing but predictions, the values that you're trying to predict, and that is what is shown on your Google when you try to, query temperature in say Mumbai, temperature in Delhi, and that's how it gives you those temperatures. Those are nothing but predictions, primarily predictions. So those are very useful for you to be able to determine whether this is going to be useful ahead or not, right? Somebody is asking, ma'am, we can also build a model which can detect. Yes, I did mention about that. So it's very good if you can build such a model code with Akash. It's going to be like very, very helpful for everybody if you can build an app or a model which can, work with mentally ill people. That's really great and very thoughtful of you to think in this direction. So all of you guys, please practice what I've told you to. You will have your code file with you. Try to create 3 different models and I want you to compare the accuracy and look at the classification reports for each of them. And since I've answered all the questions on the Q&A, I think, okay, somebody's asked, should we learn about PyTorch on our own? Would that be helpful? You can learn about PyTorch if you want, or we could also have a bootcamp on it. I would suggest that to the LetsUpgrade team accordingly, since I see the need for it. But yes, it would be a great starting point for you to be able to experiment with applications. So there wouldn't be nothing in the doc right now. I will share it with the LetsUpgrade team, the PPT as well as collab link, and you will get it over there. Post the session. Building a model to detect the disaster is great, useful. Yes, of course, if you're able to predict that, okay, there's going to be an earthquake, no better thing than that, right? Like, I mean, lives would be saved. Everybody would be safe and we would not cause so much catastrophe as we are causing right now. Right? You will get all the resources once I share with them. I will share with them in an hour. So I don't know when they will upload it, but definitely before tomorrow's session, you will get it. So don't worry. All right. Everybody's good with this? Okay, then. I will see you tomorrow. And hoping to see you on day 3, where you should be very excited because we are going to be doing a lot of visualization, and also we will deploy this particular example on Streamlit. So since we will be doing that, it's nothing but publishing your own app on Streamlit, which would be very, very interesting for you to learn things and how we can deploy things and how we can make them useful. So we'll see you tomorrow. I hope you all are equally excited to do that. So thank you all for joining. I will see you tomorrow.